So this Lunch and Learn is about uh, fundamentally this keyboard that I've been working on here, and kind of what series of interests and fields of study like led me to care about building the type of keyboard that I'll describe later. And that is primarily the philosophy of language. As a bit of a background on myself, I did my like master's thesis and studies in the philosophy of language, in particular the semantics of truth. So what does that mean? So basically it means when you say that something is true, what does that mean on like a practical level, but also on a theoretical level? If something is true, what does that mean? So there's like straightforward examples of what something being true means. So if I say there's a chair over there, it's true just in case there's a chair over there. And we have like straightforward empirical ways of checking that. I go over there, I sit down, chair over there, we're good. And for a lot of people, that's like the level of which they care to think about truth. Like, is this actually the case? But if you start looking around the edges and thinking about it linguistically, you start seeing that there's like some fuzzy areas to this field of study. So um, you can imagine a more like abstract question like 2 plus 2 equals 4. Okay, so this seems true. In fact, this is like the paragon case of truth in a lot of instances. Like in your philosophy class, you might think relativism can't be right because I know for sure that 2 plus 2 equals 4. That's guaranteed. Mathematically, I can show that, etc. It actually turns out that mathematically, that's a more interesting question than you might think. And given some theories of mathematics, it's interesting. So like, I don't want to go into the mathematics too much, but you can think of like adding one heap to one heap equals one heap, or one drop of water plus one drop of water equals one drop of water. So at least practically speaking, it's not always the case that 1 plus 1 equals 2. And depending on your theories of math, you might also make room for 1 plus 1 equals 1. But there's also other examples that are kind of linguistically interesting. So a common example that we would talk about would be the average American family has 2.5 children. So here you have like a concrete thing, like you can go out and like meet families, and you will hopefully never encounter a family with 2.5 children. The half might be a big sign of alarm. But we say it's true because it's a good guiding principle. It represents some mathematics that we have of averages, and we can base a lot of like policy off of it. Like, what's the expected growth of the country? What are we going to need in terms of agricultural resources? Like something as kind of weirdly abstract and concrete as that the average family is 2.5 kids can be really practically guiding. So that's what I kind of wrote my master's thesis on, and that is a particular field in the philosophy of language. And I think what got me hooked on the philosophy of language is just how strange of a phenomena language is. So for one, at least up until recently, human beings are the only known entities in the whole universe that have anything that you could describe as a robust language. Obviously, other species can communicate, and maybe have even like intricate ways of communicating, but there's nothing in the form of like syntactical, semantic communication happening with other species. Uh, you know, we'll talk about AI a little bit later on. Maybe we're no longer alone in the universe. Maybe AI is actually a linguistic being, and that's a very interesting and perhaps alarming thought. But we're really unique in this. It's also interesting that different cultures have different languages, and what I've found like preoccupying my mind a lot is what language is and how it functions for us as a species. So I think we typically think of language as a communication tool. And for sure, language is a communication tool. It's something we use to communicate. It's what I'm doing right now. But the only reason language can be a communication tool is because internally we have some linguistic capacity and way of thinking. So this is a point that Noam Chomsky would make. Noam Chomsky is known more for politics, but he's a linguist. And one of the things that he argued is that language is the means by which we think rationally or logically. Like the fundamental aspect of language is that it is a logical or rational way of thinking. So I imagine that you, like me, when you're working on something and you're not talking to anybody and you're trying to work through a problem, there will be linguistic things happening inside of your head. You'll say, well, we want A or B to happen. In order to get A or B to happen, I have to do this. Right? And this is oftentimes straightforwardly linguistic in your mind. And not even abstractly linguistic, it's typically linguistic in your like dominant language. So like if you're a native English speaker, you'll be thinking about this in English terms. And there's um there's some interesting implications about what might be limiting in this way of thinking, but it is the fundamental rational aspect we have. And what's interesting is people that are deaf, for example, you might think, oh, well, there's not like a straightforward linguistic way of thinking. But according to studies, at least studies that I've read or aware of, they still do construct their language linguistically. It's just they do so by thinking of the images of the signs that make up their language, of sign language. Or I've also heard that it's not even necessarily visually, but even the somatic feel of making the signs is how they process like uh, step by step rational thinking. And so that's like really fascinating that we as human beings don't just communicate through language, but it actually structures the entirety of our thought. And that structure, to kind of make our way towards the keyboard, that structure is made up of a bunch of different symbols. And those symbols, it depends on how abstract you want to get, can be a sentence, can be a word, can be a character. And I actually think it was probably something in my childhood that triggered me to think and care about symbols, that got me to care and think about language later on, and then do the things and study the things that I did in college. Um, and it might have been Dragon Ball Z originally that really got me into it. All these like awesome symbolic hand movements, or Yu-Gi-Oh or something, I don't know. But the like movements of hands conveying or making like changes in the world, in the form of Dragon Ball Z, like you're shooting this giant energy beam. In Yu-Gi-Oh, I don't know. I never actually really watched Yu-Gi-Oh. I just remember a lot of like hand movements. Um, those are kind of trivial examples, but that just like seems so cool to me that this like physical, somatic movements of your hands can convey meaning. And I do have a couple images that I want to share with this. So let's see here. I need to go to Chrome. This Chrome. Let's see. So this is an image of Christ, I think. Is this one from, this one's not from the Hagia Sophia. This one is from, it's not coming to me right away. But this is a very common sort of image that you would see of in religious iconography. And if you look at religious iconography in religions across the world, I mean, I think Buddhism is probably even more like famous for this. You will see hand gestures all over the place. And these hand gestures convey meaning. It's not exactly like sign language, the way that like typically sign language conveys in terms of words. The religious iconography conveys something of like a concept, like a whole concept or meaning of the universe or something along those lines. So this image here, along with, oh, I didn't put the other one in here. So this image here is, you can kind of recreate it by putting your ring finger and your thumb together and holding these two up your ring or your index and your middle finger and your pinky out. So this is a sign that has multiple meanings. In some ways, it's supposed to spell or represent the first two characters of Jesus Christ in the Greek. I don't fully understand how this actually successfully conveys that. I've read some diagrams. I've never felt like I fully got like how the two C's are getting in there or whatever. But on another level, the message that's being conveyed here is part of traditional Christian theology. So the three fingers standing up represent the Trinity, the triune doctrine of God, that God is Father, Son, and Holy Spirit, three in one, which is a core Christian doctrine from a very, very long time ago. This has been like the defining characteristic of Orthodox Christianity, Orthodox little o. So Catholics, Greek Orthodox, mainstream Protestants all affirm the doctrine of the Trinity. And also the two fingers coming together represent the incarnation, that you know, Christ, the part of the Trinity, becomes man. So you have two in one. And it's interesting to me that this hand gesture can mean that. And this has been recorded over and over in icons and has impressed this theological doctrine for Christian believers around the world through centuries. Similar kind of things happen in Buddhism. This is I think this is a Buddhist like examples of hand gestures in Buddhism. You see a lot of these like in modern culture through the practice of yoga. So like bringing your hands to heart center, if you've ever done like Rodney Yee yoga, like that conveys a meaning of tranquility and peace, as does certain other images of like the Buddha with his hand up and his hand out, of like giving and receiving peace and tranquility into the world. I think like, what's a good angle here? This one means like wisdom. And so we have these symbols meaning something and conveying and reinforcing, if not ideologies, at least thoughts and beliefs in people that are practitioners of these religions. And again, if you go back to this idea that language is the structure of thought, and language is fundamentally about symbolic representation of ideas, it's interesting to see how various hand gestures and sign language and things like that can convey a thought or a concept to another being. In essence, like in this communication of like art and hand gestures and the like and sign language, you're not just communicating in like a vanilla sense, or to impact what communication is more, you are taking part of your cognitive activity and inputting that cognitive activity into another person. Like it's an incredibly powerful, interesting thing that's happening through the exchange of symbols. Symbols represent our thoughts. We represent our thoughts verbally in like spoken language, but also symbolically with hand gestures, sign language, etc. And that's just a mind-blowing thing. You know, like by doing something like this, I represent a a piece of my mind and my thoughts and my beliefs physically in the world, and then that gets conveyed into your head, and now you have that thought in your head. It is almost like a functional input of my thought through the medium of a hand gesture or verbal communication is now your thought. It is in your brain. That's absolutely wild. Um, so this is kind of these hand gestures. I always loved doing this with myself when I'm just like bored or like driving. I'll oftentimes like catch myself like making hand gestures, not the road rage hand gestures that you might imagine while I'm like driving through the incredibly dense traffic of Indiana, but more just like passively recreating iconic hand gestures that I've seen. It's just something, I think it's pretty idiosyncratic. I don't think there's anything particularly interesting about me doing that. But it did lead me down the line of trying to think about keyboards, which are another thing I find interesting, and how you might be able to type or input into a computer through hand gestures your thoughts. So if you're writing like a book or something like that, when you type on a keyboard, you are doing a very like linguistic thing. When you're not communicating with another person, you're communicating with a machine. You are taking a piece of your mind, representing it in a linguistic form of characters on a Google Doc or something along those lines. But wanting it to be kind of more somatic, less like just type one character at a time. Like, is it possible to represent characters and words successfully through hand signals? Uh, the answer is yes. And one person, I mean, I feel like it's pretty obviously yes, but it's interestingly yes. And one person that really provided a lot of insight in how this might work for like chording your hand together to create different characters was a guy named Louis Braille, which is this fella here. Louis Braille is famously the inventor of the Braille alphabet. I'm assuming everyone here is familiar with Braille. I don't think that's like an obscure thing. So he was blinded at the age of 3, I believe. And he went on to invent an alphabet that could be read by running your fingers over, what is the opposite of indented? I'm just going to call it outdented. I don't think that's a word, but I'm going to use it. Through outdented dots on a page. And what was really interesting about this is you could represent easily all of the characters in the English alphabet using just six dots. And I'll show you an example a little bit later on with kind of a slightly reworked Braille alphabet. But with just 6 characters or with 6 fingers, you can represent, what is it? 2 to the power of 6 characters. So in this case, 2 to the power of 6 is going to be 64 characters. You might have to take one away because one is the null where you're not doing anything with your hands, but 63 characters, which is about the same size as your average keyboard, which is fascinating. So with just these 3 fingers, or 3 fingers on this hand, 3 fingers on this hand, you can represent all of the keys on a standard keyboard. Now, it's a little bit difficult because it's not like a single key press, but you can do it with just these 6 fingers. So I'm going to share another bit of my screen, and I'll show you some more of what I mean. So this is what I've been, I think, unproductively obsessing about lately. So I wanted to build a keyboard that used the Braille alphabet. Now, I don't know Braille. I've never studied Braille. And Braille is not the most ergonomic alphabet to represent with your hands. In fact, we can actually just look this up really quick. I think it's primarily designed to be easy to feel as you run your hand across paper. But some of these are pretty hard to represent with your fingers. So for example, N here, N would be these 2 fingers and these 2 fingers. And chording those at the same time, you can see it. My middle finger keeps wanting to go down. So when I rewrote my alphabet, when I wanted to do the Braille alphabet, I did the Braille alphabet, but I put a lot of thought into the ergonomics of the Braille alphabet and how to be able to do it more easily with your fingers on a keyboard. Because again, Braille's meant to be read as you run your finger over it. So I came up with this alphabet, and I actually, I'll come back to the alphabet in a second. I did a lot of thought on what the ergonomics is. I came up with multiple criteria of how the ergonomics should be constructed, mostly by trial and error. So I took these 3 fingers and I did a bunch of typing on this little keyboard that I constructed that I'll show and talk more about in a minute. And through that trial and error, I represented the ergonomics of chording keys with these 6 fingers through Is it four or five criteria? So one criteria is the easiest to press is just one key. That's the easiest. 1, 2, 3, 4, 5, 6. So that's 6 keys that you get right here. So 1 through 6. The next easiest, well, these two are kind of tied, is adjacent fingers and mirroring fingers. So if you press your index and your index together, like character 9 here, that's a really easy thing to do. And so is your index and your middle finger together. And so you see that the index or the mirroring and adjacent keys take you all the way up to 18. So you can get 18 characters with the very ergonomically friendly single keys, adjacent keys, mirroring keys. And then after that, I have a category called asymmetric keys. So these are keys that as you type between your two sides of your keyboard with these 3 fingers and these 3 fingers, you're going to get not a mirroring relationship. You're going to get an asymmetric relationship. So for example, 19 is left index finger, right middle finger, and 20 is the opposite of that. This is still pretty easy to handle ergonomically. There's nothing about the structure of your hands, which are kind of weirdly structured for this type of typing, that make that difficult. What gets difficult is the last category, which is the split fingered typing or chording. So split finger is when you have 2 non-adjacent fingers on either side of the keyboard. So starting at, where is it? 46, you have the first split key. So you can get up to 46 keys in an ergonomically friendly way. But then after that, it gets really hard to start like typing and chording things successfully. So that's how I split up the keyboard into different ergonomic types. And I've got these different ways of showing this. Oh, I should also say, by the way, I named my keyboard in a name that I don't think is objectively good, but I absolutely love it. The Symbolicon. Because it was like thinking about symbols and icons that got me to care about this. And then I was like, okay, that's a sick name. I have a GitHub repository now called Symbolicon that holds my firmware and all that. So I also represented, like, you can sort through this data by looking at the number of keys that are being pressed, which is interesting because I think on an intuitive level, you might think that the easiest to hardest is just going to be a numbers thing. Like 6 is going to be harder than 1, and everything's going to basically fall evenly in between that range. But as you can see, while that pattern is more or less true, the smaller numbers in terms of ease of use are earlier on in the list. Number 18, which is all the keys at once, which is a mirroring relationship, is number 18. So it's pretty easy to do, but it's the most keys that you can possibly press with 6 fingers. So it's interesting that the number isn't at all what determines this. It's like the structure of your hand and the ergonomics of it. And then this is sorted by type, where you can see the single, the adjacent, the mirroring, the asymmetrical, and the split fingered. Also on here, I have, you can see this by row, in case you find that easier to read what's going on. Instead of thinking like this, you're thinking like this. That's just something for when I'm actually trying to learn how to type on this thing that I built. It can be easy to switch between these depending on what you're doing. All right, so let's look at the actual keyboard. This is the keyboard that I bought. Well, this is a kit. You had to like solder some bits together, but this is a Korn 5-column keyboard. There are 36 keys on this keyboard, and there's a little microcontroller unit that you solder onto the board, and then you just hook all the keys in. And then the microcontroller unit you can program using firmware called ZMK, which is a super cool keyboard firmware programming language. And it runs on this open sourced operating system called Zephyr. And Zephyr is a RTOS, which is a real-time operating system, which is great for firmware and like controllers because it lets you know deterministically what's going to happen in what order. Whereas like schedulers on regular operating systems, I think there's ambiguity as to when things are going to actually be executed. I don't know a lot of the details about this kind of stuff, but from what I understand, that's the kind of nice difference and why it makes for good firmware, a good base for firmware. So yeah, there's not too much to unpack here. This is what it looks like. This is where I bought it. It's so disappointing how expensive keyboards are. There's nothing, it feels like there's nothing you can do to like make a keyboard cheap, except for maybe there's a site called PCB Way where you can design your own PCB and maybe get those cheap and then 3D print your own case, but I wasn't about to do all that. I thought about it for a long time. In fact, I was waiting to build it. And then at some point I was like, I can't. I'm never going to actually learn how to build my own PCB. And so I just did this. But with my keyboard, it's a little bit different. I'm going to stop sharing now so it's easier to see. So I have taken out all but 10 of the keys, as you can see here. And you just set it down and you chord away. And each one of these 3 keys here, sorry, these are the typing keys. And then this is a layer key or the space key. And then this is a layer key or the escape key, depending on whether or not it is pressed or held. So if you're just typing and you hit this button, it'll be space. But if you hold it, I think for more than 200 milliseconds, it'll change the layer to, I think this one is the symbol layer. And I can show the different layers here. So here you can see I've got the keyboard split across 4 layers. This is the alphabet layer. That's the default layer. When no layer keys are being held down, you're in the alphabet layer. You can also, on the left hand of the keyboard, the pinky key, which is not a typing key, if you hold it, it's not a layer key, it's just shift. So you can get all your capitals without shifting layers, which is really nice. And you might be thinking shifting is changing layers, but some technical jargon that I'm using makes it not a layer. It's just a modifier of the layer. This is the symbol key, or the symbol layer. Again, I went through some effort on here to try to think about what keys are going to be pressed the most often. And also like some conceptual work about what's going to be easy to remember while I'm typing. Because unlike on a traditional keyboard where you can look down and see all the characters that you're typing in, there's no way to do that on a corded keyboard. You have to just know what you're pressing and what it's going to output, which is a lot to remember. And so having little heuristics can help. So for example, even though the colon is a pretty common character in JavaScript, it is represented with a fairly not ergonomical key press, the split. That's because it's just so easy to remember that pressing the split like that looks just like a colon, that I put it there. I don't know that that's the best decision. I'm going to have to run through some trial and error to see if that actually works out. But that's what I'm working with. And you can see, even in the alphabetical layer, not everything here just follows a straightforward ergonomic pattern. So this is in alphabetical order. If we put it in terms of the frequency of the characters, which this was a list given to me by ChatGPT, so there's probably some level of wrongness here. That T, again, is the second most common letter in the English alphabet, per what I read. But it got a pretty ergonomic one, but it didn't get the second most ergonomic key, which would be the left index for me because I'm right-handed. Again, that's because that just feels like T to me. I don't know why, but the 2 index fingers at the top just kind of reminds me of the crossbar of the T. And so there's some conceptual work that is like overriding the straight up ergonomics of this. In fact, there's even a split key that I put in here, I think. Was it W? Yeah. The 2 split fingers just felt like W to me. And so you're throwing in some bad ergonomics for the sake of mental space while you're typing. And you see this in the symbol layer, like I said, with colon. Um, but also I wanted to keep things that I felt like were similar in my mind, similar in typing. So with what is it, like the brackets you can see, like the brace are these three fingers for the left one and these three fingers for the right one, and uh the array brackets are these two fingers and these two fingers, and the diamond brackets or whatever you call those arrows, this finger, this finger. So some of the conceptual work going into this is prioritizing ergonomics, memorability, and frequency of characters. And I think I've struck on a pretty good first try. Maybe I'll go in and switch some things up. This is also not all the characters that you could possibly type, but it's all the characters that I think are likely that I'm going to type, and I can just throw more characters in given my ergonomics map that I have. I've got like 35 more characters available here if I need to start throwing other stuff in. This is just a list of the most frequently used JavaScript characters. Um, and it covers, I think, pretty much everything I ever type, short of, is underscore on here? I should put underscore on here. Version 2 will have underscore. The next layer is the nav layer. This is definitely going to have to need some more iteration, but it has the arrow keys as well as like the command keys. I might split these out and do some stuff there. I might even put the command keys on all of the layers except for the alpha layer. What's nice about this is it's really easy to navigate around and like select like a line or select a word while you're in this layer. Like that's a pretty straightforward thing to do because the commands are all on the left and the arrows are all on the right. And so you can like hold the Windows key while you're navigating around and that'll select, the line that you want. And finally, I have the numbers layer, which unfortunately, obviously there's no way to do all 10 on just 6 fingers, which is a single key press. So I had to do some adjacents in there, but this is all very ergonomical and easy to type and pretty straightforward. Now, the last bit that I'll say about this is that I find this remarkably satisfying to type on until I have to start switching layers because one, I don't have the logic of that totally sorted out in my firmware yet. It doesn't seem to be working the way I expect it to. But also two, it's like just a little bit of more conceptual overhead because now you're chording with these 3 or these 6 fingers plus one layer key at the same time. That's a little bit difficult. The memory pattern is also a little bit messed up between layers because you're remembering chords as the alphabetical characters, and you're remembering them as symbols, and you're remembering them as navigation, and you're remembering them as numbers. I think that this problem will just melt away with time. It's going to be like a pattern of learning, like getting that, training my AI system to generate the right finger presses to represent the right characters. I think it's just a matter of uh, memory time and usage. All that said, the most disappointing part of all this, I think, is that I don't think this will ever be a daily driver keyboard. It might be, but if I can get up to 40 words a minute on this keyboard, I'll be really happy with that. And that might be the limit at which I'm like, okay, this is the keyboard I'm using because I built it and it's very comfortable because you never have to move your fingers around. It's all just right there. But right now, my record is 10. And that's on monkey type, which is there's no symbols, there's no capitalization, I think. Everything's just lowercase, like short words, super easy to type. Um, and my average is probably 4 or 5. That being said, like I said, I haven't spent much time actually doing this yet. So I think I can get it up to 25, 30. Be really happy if I get up to 45, 50. My normal typing speed is like 62. I'm not a fast typer anyways, mostly because I'm just messing up all over the place. I don't know if I just didn't get a computer early enough in my childhood or I didn't play enough video games or something, but it's not totally there. I felt like, oh, Now, one other thing that I think is really cool about this keyboard is that I think it has a pretty strong case for a mobile application. So as we start seeing more and more people walking around with the Apple Vision Pro 2, and people start setting up more and more virtual workspaces, one thing that I think will be really hard to actually transition to a virtual workspace will be the tactile feedback of how you're typing. Like you can generate, I think, a virtual keyboard and type on that, but you're not getting the physical sensation of where your fingers are landing. Your hands tend to wander around, and that messes up the system. The nice thing about this is you could easily build this into like a small, like two handheld things that you could just click like this. Or if you had the technology, which they for sure have the technology to do this. In fact, the Apple Watch can do some of this stuff. You can read muscle contractions in your fingers. So you can imagine if each finger had a ring, you could just type like this. And it would just be reading which fingers are contracting and then sending that information off to your OS that actually like or maybe some like Bluetooth thing that's connected to your computer to process what keys are actually being pressed. And I think that would be freaking awesome. Because then, like, if you're commuting, you can just be like vegging out with the Apple Vision Pro 2 and then doing what I'm doing all the time already, which is just sitting there and like pointlessly going through hand gestures that you've seen um, your whole life. Only you can actually be doing productive typing things. And I've got other ideas about how this could be extended and made.